Welcome to the lesson on continuous or continuity over an interval. So really it's part 2 of the lesson on continuity. I think in the continuous lesson I kind of define this. So we define continuity at a point A, but now we're going to say a function is continuous. I better say that, is continuous on an interval if it is continuous at each point on the interval. It is. Okay, so for example, let's consider an example like is f at x continuous on, let's say, all real numbers. So that's our interval, the set of all real numbers. So as an interval, that'd be minus infinity to infinity. And then looking at that, you probably know that no, it's not. Why? Well, graphing this would give you know there's a horizontal asymptote at 1. Right? So we get that asymptote, and then what does it look like? For the rest, it would look like if x were 0, it would look like this. So f at x is not continuous at x equal 1. So why? Because if you remember, what do you call that asymptote? That's there is an infinite discontinuity, or you could just say it's an asymptote. That's what an infinite discontinuity means. Okay, so not continuous on this interval because it's not continuous at a point on this interval. Now here's the one that throws people off. Is let's say f at x plus square root of x plus 1 is continuous on its domain. So just let's graph what this looks like. So x plus 1, that's a square root function. Square root function looks like that, but it shifted 1 to the left. So that's f at x. That's x. That's y. So the domain, that interval we're looking for is the set of all x real such that x is bigger than or equal to minus 1. Okay, looking at this function, it looks like you want to say yes. It looks like it is continuous, right? There's no jumps, there's no holes, there's no breaks. It looks continuous, right? If I put my pencil there and I started, I don't have to lift up my pencil, right? It's, there's no break, no spot where I have to move. So it looks like you want to say yes, it is continuous. But here's the problem. But is it continuous at x equals -1? And so let's go through our criteria. First criteria is f at -1 has to exist. And does it exist? Yeah, it exists. It's 0. The second criteria is, does the limit as x goes to -1 of f at x exist? And here you might be saying, uh-oh, because clearly our right limit exists. Limit as x goes at 1 from the right of f at x equals 0, but what about the left limit? Right? Why is the problem? Well, I can't take numbers smaller than -1 because that's not in the domain. So the left limit, it doesn't exist. So does that mean we're going to say that the limit overall doesn't exist? And the answer to that is sort of tricky. Well, it's not tricky, but it's going to force us to define something in a new way. We would say this limit, technically it doesn't exist because it only exists from the right side. But if a function only exists on one side of a domain, if a function only exists, or an interval exists on the oh, you know what? Hold on. Let me just forget that. Oh, I know. One by one. Okay, so this thing right here, the limit exists from one side but not the other. That is a special concept which we would say, if it exists from the right, the limit from the right side is equal to 0, which does equal the function at that 0. So if f at -1 is equal to just the limit from the right, so not equal to the limit from the right, then we say continuous from the right. Okay? And then if it existed from the left, then we'd say continuous from the left. So looking at that makes sense, right? It's continuous from the right. And in this case, since the function does not exist to the left, then continuous overall would be understood to mean continuous from the left. Right of -1. And if a function does not exist on one side of a domain, like that example, then continuous on the interval just means continuous from the left or right, whichever side is appropriate. Then continuous on the interval means continuous from left or right at that point. Left or right, whichever the case. In this case it was from the right, but if it was on the other side it would be from the left, right, at the end point, right, because it was just the end point which was the issue. Okay, so this function we would say then, since it's continuous from the right and it's not defined on the left, then yes, therefore this is continuous because it's because it's continuous at every point, just normal definition, and then from here it's continuous from the right, and it doesn't exist from the left, so it's continuous overall.